Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Thank you. Right. We continue the discussion of the solutions of the problems that have appeared in the IIT JAM Mathematics 2024 examination. In this video, we discuss the solution of a problem from sequences and series of the real analysis. And it is a multiple select question for 2 marks. There can be more than one answer. And the question number carries the serial number 31. And this question is suitable for all these examinations. In particular, it is suitable for the aspirants of CSIR NET and GATE Mathematics exam. Right. The given question is, let n is equal to 1 to infinity, be a sequence of real numbers. Then which of the following statements is or always true? We are given 4 options. Option A, sigma n is equal to 1 to infinity an converges absolutely. Then sigma an square converges absolutely. Option B, sigma an converges absolutely, then sigma an cube converges absolutely. Option C, sigma n is equal to 1 to infinity an converges, then sigma an square converges. Option D, sigma an converges, then sigma an cube converges. Right. Let's now discuss the solution of the problem in detail. We are given a sequence an of real numbers. We call on both the options, option A and option B, in which it says if sigma an converges absolutely, then what happens to the series sigma an square and an cube? Do they converge absolutely both, or one converges and the other is not? Let's now discuss these 2 options. Now, sigma n is equal to 1 to infinity an converges absolutely. It is given to us. Then that means sigma n is equal to 1 to infinity mod an is convergent. Right. Since sigma n is equal to 1 to infinity mod an is convergent, limit n tends to infinity of mod an is 0. Why? It is a necessary condition for any series to converge is that its nth term must approach 0. Right. Right. So, since limit n tends to infinity mod an is 0 and there exists a natural number capital N such that mod an minus 0 is less than 1 for all n greater than or equal to capital N. We have taken epsilon is equal to 1. For epsilon is equal to 1, there exists a natural number such that mod an minus 0 is less than 1 for all n greater than or equal to capital N. That is, mod an is less than 1 for all n greater than or equal to capital N. Note that for any alpha coming from the open interval 0 to 1 and a k any natural number, we have alpha to the power of k is less than or equal to mod alpha, less than or equal to alpha. This is true for any alpha belongs to the open interval 0 to 1 and k is any natural number, finite. We have alpha to the power of k less than or equal to alpha. So apply this here. So now mod an to the power of k is less than or equal to mod an for all n greater than or equal to capital N for any k fixed finite natural number. Why this happens? This happens because mod an is less than 1 for all n greater than or equal to capital N. Right. Now that means mod an to the power of k is same as mod of an to the power of k. Mod an to the power of k is same as mod an to the power of k is less than or equal to mod an for all n greater than or equal to capital N for any k belongs to n. Right. Why? Because mod of an to the power of k is same as mod an to the power of k. Agreed. Now we use the direct comparison test. Since sigma an is convergent, sigma mod an to the power of k, that series is also convergent. So we recall the direct comparison test. Suppose there exists numbers, capital N belongs to n, natural number, and m greater than 0, such that 0 less than or equal to a suffix k is less than or equal to mck for all k greater than or equal to n, then if sigma a ck, the right hand side, converges, then sigma ak, the left hand side, converges, and the sum will be sigma k greater than or equal to capital N of ak is less than or equal to m times of sigma k greater than or equal to capital N ck. What happens to this sum? That's what it says. Right. If sigma ak diverges, the left hand side diverges, then the right hand side also diverges. Then sigma k is equal to 1 to infinity ck diverges. So by direct comparison test here, sigma n is equal to 1 to infinity of mod an to the power of k is convergent. Why? Since sigma n is equal to 1 to infinity, mod an is convergent. So thus what we have proved, this implies if sigma n is equal to 1 to infinity an converges absolutely, then sigma n is equal to 1 to infinity mod an to the power of k converges. An to the power of k converges. It is with mod it is convergent. That means with mod it is convergent means it is convergent absolutely. Absolute convergence always implies convergence. But this also converges. A to the power of k converges absolutely. We are talking about absolute, therefore mod a to the power of k is convergent. It will imply sigma k n is equal to 1 to infinity a to the power of k converges absolutely. Right. So thus option A and option B, both of them follow from the above discussion for k is equal to 2 and 3. Note down, this is a general proof we have constructed. What this general proof says, if sigma n is equal to 1 to infinity an converges absolutely, then sigma n is equal to 1 to infinity an to the power of k converges absolutely for any k positive integer. This is a general result, what we have proved. If you put k is equal to 2 and 3, options A and B will come, and they are also true. So thus option A and option B are true. We move to the next slide. Right. So we consider here option C, that is sigma n is equal to 1 to infinity an converges, then sigma n is equal to 1 to infinity an square also converges. Right. For this we give a counter example. consider the series sigma n is equal to 1 to infinity a n, where a n is minus 1 to the power of n plus 1 by root n. What are these? These are the alternating harmonic series. So it is an alternating p series for p is equal to 1 by 2. Alternating p series. Alternating p series for p is equal to 1 by 2. Right. The series sigma a n, that is sigma minus 1 to the power of n plus 1 by root n, converges by alternating series test, that is the so-called the Leibniz test, where we see each term is positive and 1 by root n, the sequence is a decreasing sequence, and limit intensity of 1 by root n is equal to 0. So by alternating series test and by Leibniz test, this series sigma a n converges. This series by alternating series test. Now consider sigma n is equal to 1 to infinity a n square. So a n is minus 1 to the power of n plus 1 by root n. A n square will be sigma n is equal to 1 to infinity 1 by n. This is clearly, it is divergent by p series test for p is equal to 1. Agreed. So that means sigma a n converges, but sigma a n square is divergent. Since we have a case where sigma a n converges, but sigma a n square is divergent, we say option C is not true. Right. We move to the next slide for the further discussion of option D. Right. The option D is sigma n is equal to 1 to infinity a n converges, then sigma n is equal to 1 to infinity a n cube converges. This is a tough option. For this, we construct a sequence a n is equal to 1 to infinity in blocks of size 3. For each k belongs to n, define the terms in the kth block. How many elements are there in kth block? There are 3 elements. What are they? A 3k minus 2 is 2 by cubed root of k. A 3k minus 1 is equal to A 3k, the next 2 terms in that block, is minus 1 by cubed root of k. Right. Now, notice that the sum of the terms in the kth block are the sum of these. So, A 3k minus 2 plus A 3k minus 1 plus A 3k, substitute, that is equal to 2 by cubed root of k minus 1 by cubed root of k minus 1 by cubed root of k is equal to 0. Right. Let now consider the series sigma a n. So this is the first block, second block, third block, it goes on. And this the sum of the terms in any block, kth block, is 0. Let Sn be the nth partial sum of the series, because we want to test its convergence or divergence. The partial sum at the end of capital N blocks is S3n. Yes, each block consists of 3 elements and we are considering capital N blocks. So S3n, the sum of the first n blocks, that will be S3n is equal to sigma k is equal to 1 to n, sum of the terms in the kth block. Sum of the terms in any block is 0. The sum will be 0 and the sum k is equal to 1 to n is 0. It is 0. So what happens? The sum of 3n plus 1 terms. 3n plus 1 terms. This is the sum of the 3n terms, that is sigma k is equal to 1 to n, sum of the kth block, sum of the terms of the kth block, plus 3n plus 1, the term a 3n plus 1. So the sum of the n blocks is 0, plus the next term is 2 by cubed root of n plus 1. Next term after 3n plus 1 will come. So this is 2 by cubed root of n plus 1. Yes, 3n plus 2, the sum of the first n blocks, they will cover 3n elements. Then a 3n plus 1 plus a 3n plus 1, a 3n plus 2, a 3n plus 2, 3n plus 1, 3n plus 2. This is the next term. So 2 by cubed root of n plus 1, the next term will be minus 1 by the cubed root of n plus 1. That is 1 by the cubed root of n plus 1. This is 3n plus 2. Here is a print mistake. It is not the same. It is plus 2. Plus 2. So in any case, limit n tends to Sn is 0. This is 0. This also capital N tends to 0, 0. This also capital N tends to 0 is 0. So in any case, limit n tends to Sn is 0. So now this, therefore, sigma n is equal to 1 to infinity, an is convergent, because in any case Sn is, limit n tends to Sn is 0. So sigma an is convergent. But we have, yes, we continue. We now discuss the convergence or divergence of the series sigma n is equal to 1 to infinity an cube. Right. So for each kth block, k belongs to n, the terms in the kth block are these ones. Cube. Take this, cube it, take this, cube it, take this, cube it. So 8 by k minus 1 by k. Now, sum of the terms in the kth block, that is a 3k minus 2 cube plus a 3k minus 1 cube, a 3k cube. Sum of the kth block, 8 by k minus 1 by k minus 1 by k, that is 6 by k. So let Sn prime be the nth partial sum of this series sigma n equal to 1 to infinity an cube. That is S3n prime, that is sum of k is equal to 1 to n, sum of the terms in the kth block. Three elements, and sum is taken k is equal to 1 to n. So it will be 3n, sum of the 3n terms, and that is S3n prime, that is sigma. In each block, the sum of the terms in the kth block is 6 by k. So 6 by k. So that is 6 times sigma k is equal to 1 to n, 1 by k. So this is subsequence of Sn prime diverges. Now S3n prime diverges, tends to infinity as n tends to infinity, because sigma k is equal to 1 to n, 1 by k. As n tends to infinity, it will be divergent by P series test for P is equal to 1. Now, note that S3n prime is a subsequence of Sn prime. If you say that the given series sigma an cube is convergent, then every subsequence of the n partial sums of this series sigma n is equal to 1 to infinity an cube must converge. But since S3n prime diverges as n tends to infinity, the series sigma n cube cannot converge. If you say if you say sigma n is equal to 1 to infinity a n cube is convergent, then every subsequence of the sequence of n partial sums must converge. But here is a subsequence which is diverging to infinity as n tends to infinity. Therefore, the series sigma n is equal to 1 to infinity a n cube cannot converge. Right. A beautiful argument. Right. Therefore, option D is not true. Option D is sigma n is equal to 1 to infinity n converges, then sigma n is equal to 1 to infinity a n cube converges is not true. So, we only have options A and options B are true. Right. The answer to this question is options A and B. That is the detailed discussion of the solution of this problem. And my personal viewpoint is that it is very lengthy, and for a student of BSc, it will be definitely be a difficult question to him. But, however, this question is suitable for CSIR NET and GATE mathematics aspirants. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. It is my earnest request to all of you is please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Right. I am sure I will be meeting all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.